So this is my first PyCon, although I've been using Python for a couple of decades. So I come from another world. I come from educators. I teach college. I'm at Bryn Mawr College, a little small liberal arts, all women's college outside Philadelphia. And so I must say that I have enjoyed all of the talks today. This is my first PyCon, so I wasn't really sure what I was going to see. It's a little bit misnamed, if I may be so bold. I come from educators thinking about computer science and teaching and languages, and here's a conference that is about one language. But that's not really what today was about. It was really about this enthusiasm that's around, the spirit around Python, and it's really, it boils over into other languages and other ways. So, I mean, even the Jupyter project that I'm going to talk a little bit started with Python. It's written in Python, but it's really about how to teach lots of languages in a particular way. So, too many words here, but my motivation for coming and talking to you today is to show you how I have used Jupyter, and maybe not everybody knows what Jupyter is, or JupyterHub. Is there anybody that doesn't know what Jupyter is? Okay, so I'm going to actually give some demonstrations of that. So I'm probably not the person that you want to hear an introduction to Jupyter. That's not what I was doing today. What I'm really going to do is show some of the advanced ways that I've used the system to teach everything that I've had to teach in the last 4 years in my computer science job. So I want to talk about JupyterHub. So Jupyter is this very nice system. Meg gave a great talk on the big picture. And so if you take everything that, if you believe Meg, and you then go into the classroom and you try to figure out, how am I going to do this? How am I going to do everything that she just described? So Jupyter is this nice system for doing computing in the browser, but it's not really in the browser. You interact, the students only need a browser, and so it's this client-server system. And so I use JupyterHub, which is this layer on top of Jupyter that allows students to log in. They don't have to install anything. And I really do, and this is sort of a goal in the back of my head, on day one, we're going to compute. So I used to, in the old days, before Josh and the Vichy, before they were born, back in the old days, I used to, give an entire lecture. These were all smart women coming in. They don't know what computer science is. I had to talk to them about, all right, you're going to be able to do this. It's going to be great. It's going to be fun. Well, I don't do that anymore. I really just start on day one, and it's like, let's compute. And we start drawing and really creating some interesting projects. And I'm able to do that largely because of Jupyter and then JupyterHub on top of that. And so these are the things, you can look at these about why you want to use JupyterHub. So if you're thinking about using Jupyter in the classroom and you think, oh, I'm just going to have all the students install it themselves, don't do that. You really need to figure out a Jupyter-in-the-Cloud solution. I haven't done it but I've heard from other people, Doug, you told me to use Jupyter, and I tried it, and it was a disaster because I had all the students. Now, this was in the early days when it was harder to install. It's gotten a lot better. But I would say if you're going to run a class, try to figure out how to do it in the cloud. And JupyterHub is one way to do it in the cloud. And you can do it yourself. You can host this machine in your own space. I think at Bryn Mawr we were the first JupyterHub in the wild, and so apparently I like to bleed a lot. I've tried a few things the first, and it's always a little bit hard, but now things are really stable. What I want to do is talk about the different ways you could use Jupyter, take advantage of it in the classroom. So I've got 4 different levels, but I don't need to go through all of these. But I do want to show you some of the more interesting ones that I've done over the last 4 years. And it has been 4 years. We started this project called Calysto. And do you know the name Calysto? Anybody know the moons of Jupiter? So this was supposed to be a clever play. It's a little bit hard to spell because we didn't spell it the right way. We stuck a Y in there to be clever, to go with the Python. So Jupyter, if you don't know, is actually JU for Julia. It's supposed to be a multi-language system of IPython. This is about a series of projects that I've been working on. And this is the Jupyter homepage. And there's one icon here. You probably recognize a lot of these icons, but not this one, not this little purple butterfly. Well, that's us. That's the Calysto project. And so what I want to do is tell you some of the things that we've developed and why they might be useful to you, or maybe with you and a colleague if you're not somebody that can develop these tools yourselves. So the first thing that I worked on with some other people, Stephen Sylvester, which was a core member of the Jupyter team, we came up with this idea of a metakernel. And the idea was that we were working on these different languages. We wanted to have all languages. So we had this idea, we were going to take every language that had ever been invented, Pascal, Fortran, Lisp, and we were going to make kernels out of all of these. And I still think this is a great idea, just sort of for the history of languages, to be able to appreciate what these, like COBOL. You know, when was the last time you wrote a COBOL program? Has anybody written some COBOL? Okay, so there are a few COBOL programmers. So it would be nice to be able to show people, for maybe students or just students of history, what these languages look like. So I still think it's a good idea, but you don't want to start from scratch on each one of those different languages. You want to have a basic framework. And so that's what Metakernel is. It's a collection of useful tools to try to make all these other languages as good as IPython. So I love Python. It's one of my favorite languages. But it's not my only favorite language. I have a few favorite languages. And so we want to make those languages be as good in the Jupyter world as IPython is, at least as much as they can be. I mean, Python is going to win on a lot of criteria, but we can at least make them as good as possible. So there are things like magics and being able to access the shell, being able to run code in parallel, for example. You don't get all of that if you start writing a new language and bringing it into Jupyter. That you would have to build that yourself. And so that's what we did. We packaged all this up to make it really easy. So if you want to create a new language, and I've got a couple of here. So I just went out, you know, when you create open source software, sometimes you don't really know if people are using it or not, unless, you know, there's a bug in it and that people will complain. But if it's working out okay, sometimes you don't really hear about it. So I didn't really know about most of these until I went Googling, like, well, who is writing import metakernel? And you do a search on that, and you get lots and lots of hits. In fact, I just heard of one just yesterday, a GNU-plot kernel. Cool. You know, who would have thought, who would think that you could go off and create an entire kernel that's just on GNU-plot. GNU-plot's a little plotting system. But there are things that are really crazy. So root is its own language. Sculpt Python was mentioned just a little while ago. That is a Python that does run in the browser. So this, in some ways, sort of breaks this client-server system down a little bit, or breaks it up in a different way. Wolfram kernel. I'm not sure exactly what that is, but I suspect what it does is it gives a Jupyter interface, and it goes to talk to Wolfram alpha, and then comes back and reports it in a notebook. So all of these languages have taken metakernel, and they built this so that you have common magics and the shell and things like that. There's a Java 9 kernel. Calysto High is it's a Lisp syntax that gets transformed into Python. Very cool. And of course, you've probably heard of MATLAB and Octave. Those are probably two of the most popular Metakernel-based kernels. Calysto LC3, that's an assembly language. So as I mentioned, every course that I've taught in the last 4 years, I've taught via JupyterHub over the web. So I'm probably the only person in the world to have taught assembly language over the web. But I did that, and it gives a common interface to all of these languages. So that's one thing that I'm really sensitive to the ideas that Meg mentioned, like cognitive load. What does it take in order to bring up a new language and train the students in order to do just basic things like enter code and debug it? There's a lot for each one of these languages, and when you're in college, you're going to get some exposure to lots of different languages. Calysto processing is probably my favorite other than Python because it takes Java and it makes it look like Python. Ooh, good idea. If you have to teach Java, do that. So this Calysto processing is a very nice way to make it so that you can still do Java, but you can do it and make it look a lot like Python and put it in this the Jupyter framework. All right, so I mentioned every course, including a first-year writing seminar class. I thought, why not? Why not try this? And I think it's going to be an interesting idea, an interesting experiment. And I'll tell you probably more about that at JupyterCon in New York later this year. But if you think about just what could you do if you could just make up a language for a particular purpose? So this is a language completely made up. So I co-taught Intro to Biology and the Intro to Computer Science, which seems like, you know, how could you do that? How could you take the introductory material to biology and the introductory material to computer science and put it together in one class? Well, it turns out when you get to college and you're taking the introduction to biology, you've already had introduction to biology. So they don't really know what they're going to teach. So it's this big open space that's perfect to slide in a little computation. So at Bryn Mawr, and this started, I think, at Harvey Mudd, they have this one course, and we call it Computing Through Biology Through Computing, yes. And so the first week of class, we wanted to have a lab. We want to have a lab every week, but we haven't taught them any Python yet. So we made up this little language that was easy enough to describe in a short time, and then this controls this little robot that's supposed to be a ladybug, and it goes around and eats food. And we use this simulation throughout the rest of the semester. We do a little bit of evolutionary programming, and so we come back to the same framework where they read a paper on foraging. So it turned out to be a nice place where you could make up your own language and stick it into a particular slot for a very specific reason. This one was for fun. This is a chatbot language. And this is really a nice example. If you want to see how to make your own language, this is, it's 75 lines of code. And it starts up, it's actually not a bad, if you want to explore writing your own chatbot, you can create the rules in this little system. And here is some sample output of interacting with this chatbot. And I didn't do anything other than just sort of package up this to provide an example. I talked about just briefly using this JupyterHub specifically in a first-year writing class. And the idea is, I'll just say a brief word about it, but we want to give students the ability to start writing with data. And my goal is to get computation up there with reading and writing and arithmetic. So I saw this as an opportunity to really explore the idea of, in that first year writing course, could they maybe enter a little bit of data? Not really write code. It wasn't about coding at all. I didn't want to spend any time at all about talking about coding, but I did want to talk a little bit about this framework and how they could take data and create a graph out of it, a little plot. So this is probably the wrong group of people to talk about Scheme. Has anybody heard of Scheme? Okay, some have. Have you programmed in Scheme? Okay, okay, maybe this is the right group. So Scheme is another Python, Scheme, C. I think those are three of my favorite languages, and they have something in common. I think that there's this simplicity to them, this elegance. Python, C, and Scheme all have this elegance to them. If you haven't heard of Scheme, it's probably a little bit hard to teach yourself Scheme. Scheme is it was a cleaned up version of Lisp, if you've heard of Lisp. And Lisp was one of the early programming languages. And so we created this Scheme over many, many years. I grew up in this tradition of appreciating this language. And so this was something that we'd been working on for a long time. And we ended up, not the first time, not the first draft, but we wrote this Scheme in Scheme. Okay, that's a weird idea. We wrote this language in itself, but then we just use that as a description and then translate it into Python. So what we have is this language, Scheme, that you can run in Jupyter. And it's written in Python, but of course you can't see that. But a little bit of work, and you can actually import libraries from Python. So this makes it really interesting. And so why would we do this? So on the left here, this is the normal way of working with Scheme. And if you haven't seen Scheme before, this is a little bit of Scheme code. This is the factorial function, so anytime you want to define any variable, you say define the name, and it could be just a numeric variable or a function. They take the same format. And you can see that the functions come after the parentheses, so this is defining factorial in a nice recursive way, and then calling factorial, and then you get a bug. You hit a bug, and you see enter debug to or type debug to enter the debugger. So they took a different tact with dealing with error messages in most schemes. Here it is in our Calysto scheme. It looks like Python. We mirrored Python error messages, and to try to make it look like it works the same way as Python. It doesn't, but it looks. So it was designed to give that same feel. We wrote a debugger in Jupyter. So this is something I believe is targeted for Jupyter Lab, but we put this into the notebook. So I can show you a demo of this if we have time. How are we doing on time? Okay. We're doing good. So I think that means I can talk as much as I want. Oh, okay. So, so here's some scheme. It's a prefix operation. This is 1 + 1. Here's a function with no name. Here's something that you can do that's very nice in Jupyter Notebooks is you can use Unicode for variables, which is really makes code look much more beautiful, I think. And in fact, we went an extra mile and said, you know what, you can go ahead and put the lambda in there. Why don't we make that actually be the same thing as the word lambda? So you can actually write these functions that way. This is a deep learning package that I've been working on. It's written in Python, but because our language can import Python code, you can see you can do some deep learning right in Scheme. And I think for some people that really love Scheme, this is really appealing because there's no other scheme. It's pretty easy to write a scheme, which is one reason why I use it when I teach programming languages. But there's no other scheme in the world that you could do deep learning in, perhaps. So in the programming languages course that I teach, we learn some Python. It used to be we teach Python in the introductory course. which would be my choice. But when you're in a department, you don't always get to make that choice unilaterally. So we're using the Java version of Python. We're using the processing. And so we have to learn a little bit of Python. And then we learn a little bit of Scheme. And then we implement Scheme in Python, which how many of you have done that? Have you written your own Scheme? Okay, a few. Lisp. Lisp is just the dirty version of Scheme, yes. So it's not that hard. The syntax of Scheme is really beautiful and very simple. Parentheses, function, and then perhaps an arguments. So this actually is fairly easy to do. I mean, to describe. It takes some work for the students to be able to do that. But number 4, this would be impossible. Implement Python in Scheme in, say, 3 weeks. Why would that be crazy impossible? The syntax of Python is, incredibly, it's beautiful when we write code, but if you actually try to parse it into its components, you could spend years on that. In fact, of course, they do. They do spend years creating very nice parsers in Scheme. But because we have this scheme written in Python, we're able to do this in a class where students don't have any background. They don't know Python, they don't know Scheme. They're coming perhaps right out of data structures. So I'm pretty happy with this. And that wasn't my original idea, but creating a new kernel in Jupyter allows things to happen that you hadn't planned on. For those of you who have done this kind of thing before, this is some Scheme code that's implementing Python. And the trick here is, of course, this very first line here, import AST. So AST is the abstract syntax tree. And then once you do that, you can just move directly from Python into this abstract form and then create something like what you see in cell 2 to turn it into an interpreter. And there's some very nice things in Jupyter as well. I encountered this show AST, and this might be something that you might be interested in just in general, to see when you type something in Python, what is the representation actually being created. And so you can just see that 1 + 1 is actually doing quite a bit behind the scenes, and show AST is a little module to create this library that you can import, and then it creates this magic that you can then see it. And you can imagine what kind of big trees you get with just a little bit of Python code. So a lot going on in Python. Okay, so that's Calysto Scheme. I'm just going to mention briefly a couple of the other things that we've done in the Jupyter stack to make things easier, better in terms of pedagogy. A couple of magics that we've created. One is activity, and a couple of the speakers have talked about doing I think was this Meg that said raise your, no, it was somebody else that said, who? Elizabeth said, here's a question, how many of you think it's 5? And you raise your hand. Well, it's not anonymous, and if you're not sure, do you raise your hand or not? So this activity magic is a way of making that anonymous and trying to get more honest feedback from students. Sometimes it's called an exit ticket. And so the idea is that when you get to the end of a module, you ask the class, okay, if this is the situation, what do you think? I have some examples here. And so everybody can answer. So here's the activity ticket. You give a little parameter to that, and so then you can ask them. You could use it as a quiz system, or just to make sure that everybody's on the same page. And then so that the exit ticket is, the idea of an exit ticket is we're on our way out, and so you need a ticket to get out, and let's make sure that everybody's on the right page. And so here, now this is my view. The students don't have this results button. They just, they're asked a multiple choice. They get to answer it, and then after everybody answers it, I click on results if we want to do it as an exit ticket way. And then we look at the, usually it's like this. Usually it's not everybody with the right answer. And so we can see that, yeah, a majority of people think it's 4, all of the above. And then we can decide as a class, do we need to spend some more time talking about this, or can we go on? So that's the idea of an exit ticket. So I thought that was a really nice merging of this idea that you would normally use clickers or maybe a phone app or something, but we can just build that into JupyterHub. And so this is written as a JSON file, and it reads in that way. Another one that Josh, right? This I think would work very nicely. If you're really interested in something like blocks, but you also want to do something in the Jupyter world, how could you combine these? So this is an afternoon experiment. This is what we call Jigsaw, and it's not a full language, it's just a magic right now. But the idea is that you can give a workspace name if you want to be able to save and then reload, and you drag and drop these onto the screen, and then you can either generate the Python code like your little Python button did. You can switch back and forth between, this is Blockly, or you can, so you can generate the code, and here I have done that, or you can just run it directly. So I think this is suggestive if somebody wanted to take this and turn it into a full kernel. Perhaps you could have different cells, or maybe just one cell with your canvas on that. And this version works with either Java or Python. It can generate Java code or Python code. We also have a number of extensions that we've created just to make it useful in the classroom. Some of these, there are perhaps better ways of doing it these days, but one of my favorites is this annotate. And I can show you an example of that. So let's go with the Metakernel here. So here I am. This is, oops, a little small. So we're doing some examples here. Download is a magic that we've added. But this annotate, if you click that, then you can come through here and you can just draw right on the screen. Now this doesn't save with the notebook, but it makes it handy if you wanted to do some drawing and mix that on top of the notebook. Okay, so I think unless you have specific questions about some of these, spelling checker, the first time I saw IPython in the notebook, I said, please, for all that's important, give the students a way to check their spelling. I have to grade these, and I really am a big believer in reflection. So everything the students do needs, everything I do too over the last 4 years has been in a notebook. On my notes, lectures, in class, live coding, I need the spelling checker as much as they do. And some of these others are just utilities for trying to manually, to make it easier to manage. And I think I'm going to not talk about this deep learning library, but I'll talk about that at JupyterCon in New York. And I think with that, I will stop, and perhaps we have time for a question or two. Okay, great. Yes. Yes, absolutely. So one thing that we can do, and like I said at the beginning of this, if this is your introduction to Jupyter, I sort of skipped all the really useful stuff. So, for example, this is just the stand. Oops, I'm in overlay. So let's close that up. So this is the normal classic notebook interface. And from here, you could download it as a notebook, and then you could email it to somebody, or you could download it as a PDF, and you could publish it. You could get HTML, whatever you wanted to do. What else? Well, it depends. Well, each one of these is a, oops, each one is a different installation. Let's see, I deleted my talk here. So each one of these, let's see, each one of the extensions, the language, the kernels, each one of those has a different installation method to it. So libraries, you would use a normal pip or Anaconda. Extension, you have to get it and then you have to enable it. The magics, these all come with Metakernel themselves. So once you get the Metakernel, you can then use those in other notebooks. There was another question over here. Yes. So I believe it or not, I do follow most of the email in the Jupyter GitHub repositories. And as far as I know, they now have the infrastructure in order to make the interface be multilingual. And I believe that they're just now getting to the point where they're starting to do the... Oh, the spell checker. Yes. Oh, okay. So I answered a different question. So is Jupyter multilingual? It soon will be. And the spelling checker is with a couple of changes in the Java script. You can make it multilingual. It's built on Typo, which is a language system for checking spelling. Anything else? One more in the back? Yeah, that's definitely a possibility, and it's something that I've encountered from the very beginning. One thing that I've done, so let's take a cell that actually has some output here. So here's a download magic that will get any URL and it'll output that. A couple of extensions that we've created have been this tabbed input. So if you do that, it hides the code, and so you can switch back and forth between just the input code and then the output that code produces. Another one that's also related is this two-column view. So now here we have the input on the left and the output on the right. So that's something that we've added that does a little bit of manipulation of the notebook, but it's not something that is supported by all notebook API, the formats. I think it should be. Maybe at some point we can get that worked in. Even when you have just a notebook? Excellent. I'm really looking forward to Jupyter Lab, which is the next step in the evolution of Jupyter. Well, great. Thank you very much.
Thank you.